Hello and welcome to another session on IT and Automation Academy's YouTube channel. In today's video, we will actually try to test DeepSeek and we'll see how effective it is for our PLC programmers, DCS and Scada engineers. We will give some interesting scenario to DeepSeek and we'll see how effective it is. Without further ado, I will directly get into the interface of our DeepSeek. Bring up one scenario here. Let's say we are working on a PLC system and input and output module is not behaving as expected. The sensor seems to be sending the data, but the PLC is not reacting. It's like communication link is broken, but we are not sure where is the problem. Let's see how effective it is. The first suggestion that DeepSeek is saying right now is to verify power supply. That's correct, that we have to ensure input and output modules powers, obviously, that every module is receiving the power supply and the voltage, correct voltage. Check for any blown fuses, that's a very good tip, or trip circuit breakers. Again, so far so good. Confirm that the PLC and IO modules are properly grounded. Again, that's an effective way to troubleshoot that kind of a scenario. So far, it's going amazingly well. The second thing is check physical connections. Inspect the wiring between sensors, IO modules, and PLCs. Great. Look for loose connections, damaged cables, or incorrect wirings. That's an effective way. Verify the sensors are properly connected to the correct terminals on IO modules. Great. Confirm. Now the next step is confirm module status. It's doing amazing so far. Check the status LEDs on IO modules. Power LEDs should be on if module is receiving power. Communication LEDs should indicate active communication with the PLCs. Yeah, that's amazing. That's good so far. IO status LEDs should reflect the state of an input and output. If LEDs are off or flashing abnormally, consult the module's manual for error codes. Again, good. So obviously error codes are different for different PLCs and we haven't specified is it a Siemens PLC or Allen Bradley, so the response is correct. The next step is review the PLC program. Ensure IO modules in the program matches the physical module configuration. Verify the program is correctly reading the input and wiring to the output. Look for any logic that might be disabling or overriding the IO modules or overriding the IOs. The next thing which is there is to test the sensors. Use multimeter or oscilloscope to check if the sensors are sending the correct signals. Manually trigger the sensors and observe if the input LEDs on the IO module change state. That's good. If the sensors are analog, verify the signal range 4 to 20 milliampere or 0 to 10 volts matches the module's expectation. That's amazing. Check the communication setting, verify the communication protocols. Obviously modbus, profibus, ethernet and settings are correctly configured. Ensure the PLC and IO modules are on the same network and can communicate with each other. That's good. Use diagnostic tools, ping network analyzers to test the communication between PLC and IO module. That's good. Inspect the IO module configuration. That's a good thing. I will not get into the detail. We'll just try to see that. Ensure the module is correctly added to the hardware configuration. It's all about checking the setting for that IO modules in the PLC program. So check for fault and errors. That's again good tip. If there are some errors coming in the PLC, then obviously we can trace out the problem based on the error logs. So look for any alarms or warning on the PLC logs. That's good. Test with a simple program. create a test program and then toggle the input and output to see the behavior. If the simple program is running perfectly fine, then that might be an issue with the code. That might give you a hint to troubleshoot further easily. So, but obviously before doing that, you have to take a active backup, so that if you wanted to retrieve that backup or recover the system to the old state, then you should have a backup for that. Consult documentation and support. Obviously, the last step is see the documentations for IO modules, PLCs, and different manuals, obviously, and troubleshooting guides can help you. Then if the problem is still there, then you have to contact the manufacturer. So that was the first scenario. Now I'm gonna ask another problem to DeepSeek. So here is the problem. The problem statement is, let's say we have a motor control system and motor is not starting when the start button is pressed. The hardware seems fine, but we are getting the expected output, but we are not getting an expected output. It could be an issue with ladder logic or IO connection problem. I'm asking this question to the DeepSeek, to see what is the response. Hit enter. So this is a specific scenario where I'm asking some technical question and see how effective is DeepSeek. So when motor control system is not starting despite the hardware appearing to be fine, the issue could be indeed related to either ladder logic program or IO connection problem. Then it's giving us a complete plan how to troubleshoot an issue, which you can see that it's asked. First thing that is there is to check the start button and input wiring. Use multimeter to check if the button is sending a signal when pressed. Ensure the button is wired to the correct input terminal on the PLC. When start button is pressed, the corresponding input LED on the PLC should light up. If the LED doesn't light up, there is a wiring issue or a faulty button. So that's so far amazing. Verify the stop button and safety circuit. Ensure the stop button is not stuck or incorrectly wired. That's good. If faulty or engaged, stop button can prevent the motor from the starting. Check any safety circuits like emergency stop, overload relays. The circuit must be closed for a motor to start. Interlocks are important, and it's getting into the right areas. Inspect the ladder logic program. Obviously it talks about in detail how to inspect it. You can check it, look for a rung controlling the motor's start. Ensure the start button input is correctly referenced in the program. Verify the output coil for the motor. That's again ensure I'm just skipping out from the details because you can see it by yourself as well. Ensure the output address matches the physical output terminals on the PLC. Check if the output coil is energized when the start button is pressed. Then it definitely talks about check the output wiring and motor starter. Verify the output wiring for a PLC to motor starter or contactor. That's good. Ensure the output terminals on the PLC is correctly connected to the motor starter coil. Test the motor starter or contactor. Use multimeter to check coil. If the coil is receiving voltage when the PLC output is activated. Manually activate the contactor to ensure its functionality. That's good. Monitor the PLC program in a real time. Check for faults and error. I'm not gonna get into the details, but so far so good. Test with a simple program. Again, that's good. Check for IO addressing issues. Inspect for power supply. Common issues to look for. Ladder logic issues. IO program. And then it talks about the basic start and stop ladder logic circuit. I would say 9 out of 10. Amazing. I think even the guy with the experience might get that kind of step-by-step procedure if he's getting with the experience, but normally fresh 2 years or 3 years experience person will have a hard time looking into that kind of a scenario. So troubleshooting wise, 9 out of 10. Let's see if we would ask a simple program for a pump control, can it write a PLC program also or not? Can you please write ladder logic program for pump control in Siemens S7 300 PLC? So yeah, I'm right away asking it. Now I'm just putting another requirement, and I can see that how detailed is the output response from that DeepSeek. So I can see that the program looks okay. There's some program, even the details are there. An explanation of the program, I can see that. So the start button is there, stop button is there, pump output is there, and then we got IS0.0. What is IS0.0? It's start the pump. 0.1 is to stop the pump. Yeah, I can see that might be, there would be, I think so, there might be stop the button, and then how it's saying that start button is pressed when the pump is okay. Even it talks about some kind of a program, and it looks good. Maybe with minor details, something which I can see here in some of the cases, it's not very clearly mentioned that where we are going to be using normally open and normally close contacts. That's one of the things which I can see from my eyes probably. But if you are a programmer, and it's easy to just correct the few instructions and correct it in a proper way, because we got a detailed explanation as well. Yeah, that's good. Even it talks about how it works in some kind of a specification notes for a schematic manager. I would say 7 out of 10 because it's a start, and it's so far response is amazing. Let's put up another scenario right now. PLC to HMI communication in Siemens S7 300, and also in a software called WinCC Flexible. That was an old version, so let's see how it reacts to that. How to communicate PLC S7 300 PLC with schematic manager. Okay, with WinCC runtime HMI. Let's see the response. It takes time, but what I can see is the response are far way better than ChatGPT. What I can see that the response are way detailed, and yeah, just a second, why the heck it's not working out? Now it takes it to communicate PLC with a WinCC HMI hardware setup. Great. Software requirements, you need a WinCC Flexible, that's good. Then set up a hardware configuration, that's good. Enable the communication in a PLC program. Configure the WinCC runtime project. Okay. PLC address, ensure the PLC address on the MPI interface. Map the tags to addresses in the PLC program that you have used. Test the communication. So what I can see from the overall quick scan of that, the response is amazing. It will give you a clear understanding where to go ahead and what to do. Let's see, now it can understand WinCC programs as well, so that's good. Now I will test a Scada to modbus communication. So I will give it a Scada Wonderware and will ask to see whether it has some kind of information about Wonderware. Can you make a program to communicate Scada name is Wonderware touch to modbus simulator. Let's see what is the response right now. So it should be okay. It is taking time. I don't know why the heck. So I can see that one issue, that it takes input very late. But yeah, let's see. So you need a modbus simulator, modbus TCP IP or RTU driver should be there in a Wonderware in touch. Ensure both Wonderware and are on the same network. Like obviously Wonderware and modbus simulator, if they are on the same network, then they can communicate. Download the simulator, launch the simulator, define the addresses. It talks about simulation values as well, and addresses. For a modbus TCP IP, it talks about setup and IP. And for RTU COM port, yeah, that's good. Install the modbus drivers. That's good. Wonderware in touch, and that's good. Modbus simulator, you have to access new name and all. That sounds like good. It's a generic one, not giving you a detailed plan, but yeah, still so far so good. I can say that 6 out of 10 in this scenario which I have seen here. Let me know if you have tested it already, or you're gonna test DeepSeek for automation jobs, and what is your view? What do you think about it? For me, it's super impressive. It would be one of the biggest hit in coming futures, and that might affect the jobs of automation engineers as well, because I can see that the job that automation engineers are doing, it can do that effectively, or it can help the automation engineers to do the job effectively. That's all for today. If you like this video, consider hitting the like button, subscribe if you haven't yet. Until next video, take care and bye-bye.